All right, happy Tuesday. I took questions on 3.6, the set 9 through 12, and the Go 13 to 21 today in class. Not too many questions on that, but if you have questions on that, let me know. The next thing we looked at is we looked at the 3.7. We looked at the set, and we looked at questions 5 through 10. And a couple of things in there. In questions 9 through 10, if you look at 9 through 10, I believe 9 is x squared minus 12x equals negative 8. And this is not the same form as 5 through 8. It's different. And the reason why we point this out is because they're adding one extra step in solving all of these by using the quadratic formula. I know the directions say solve using any method. No, you need to solve using the quadratic formula. By the time you get done doing your work, you'll have 3 of these questions to do, which, by the way, take a scratch piece of paper and go ahead and divide that into 4 sections like you did for 3.6. And this is where you're going to show your work. It even says, the directions even say on a separate sheet of paper, show your work. Okay? Again, no work, no credit. But here's how we're going to tackle this. Every problem that you take, and I'll just write down question number 8, because a lot of students say, oh, question 8's the hardest, question 8's the hardest. When you look at question 8, you get 3x squared plus 14x minus 5 equals 0. And when you look at this, everybody thinks it's hard because you see some big numbers and a is 3 and so on. Well, it's not. This is standard form. Ax squared plus bx plus c equals 0. This is not. How do I make it 0? I make it 0 by adding 8 to both sides. If I add 8, I get 0 is equal to, you may not combine this, x squared minus 12x plus 8. Now I can list a is 1, b is negative 12, and c is positive 8. C is not negative 8. You have to make that manipulation in 9 and 10. Otherwise, your answers are not going to be correct. All right? So there's part 1 of today for the video. The other aspect of this, and again, I'll do question number 8 because it looks hard, is again, just reviewing the process of the quadratic formula. First off, identify A, B, and C. Well, here's my A, B's, and C's values. So 3, 14, and negative 5. That's step number 1. Okay, step number 2, substitute. Well, there's a couple of parts to this substitution. I'm going to rewrite the formula. And if you look at the formula here, remember the minus out front. The 4 is part of the formula. A couple of things I ran across today. 4 is always in the formula. So minus whatever b ends up being, plus or minus the square root of b squared, minus 4 times a times c, all divided by, all of it. Another thing I ran in, some people wanted to divide this part by 2. No, you divide all of it by 2, and by 2a. So now that I've rewritten the formula, you just come back and wherever a is, you put a 3. So right here and here. Wherever b is, you put a 14, here and here. And wherever c is, you put a negative 5. Right there. There's only one c. Done. Now step 3. We're already at step 3. Simplify. So we want to manipulate this and get to an answer. We want to shrink it down. Remember, it condenses rather quickly. So x is equivalent to minus a positive 14, which is negative 14, plus or minus the square root of 14 squared. Well, 15 squared is 225, so 14 squared, a little bit less than that, 196. Use a calculator if you're not sure. You should have one for manipulating this stuff. Is it 196 plus or 196 minus? Well, a negative times a positive is negative. Negative times negative is positive, so 196 plus. 4 times 3 is 12. 12 times 5 is 60. Don't need the rest of that. All divided by 2 times 3, which is 6. I can simplify this, so I'm going to go x is equal to minus 14 plus or minus 196 plus 60. Well, gee, 256 divided by 6. If you're not sure, again, let the calculator do the work for you. I don't mind if you use it. All right? Now when you get to this point, we want to look at this and see, is this a perfect square? So if 256 is a perfect square, then it's going to be equal. If 256 is a decimal, it's going to be approximate. So in this case, 256 is actually equal to 16. It is a perfect square. It's at this point where if this ended up being a decimal, my answers down here are probably going to be decimals. If this is a whole number, my answers down here are probably going to be whole numbers. And I say probably, and you'll understand why I say probably in a few minutes, okay? So I made that, by the way, in case some of you were wondering. When we manipulate this again, I'm going to get x is equal to minus 14 plus or minus 16 divided by 6. This is the point where I separate, and I have two problems, 1 plus, 1 minus. So separate this again. X is equivalent to minus 14 plus 16 divided by 6, or minus 14 minus 16 divided by 6. Right? 1 plus, 1 minus. 1 plus, 1 minus. So what do I get? Well, minus 14 minus 16, that's 2 over 6. Minus 14 minus 16, that's minus 30 over 6. So what do we get? X is equivalent to what? 2 over 6, don't tell me it's 3. You can tell me it's 1/3. And this becomes negative 5. So here's my two answers. Now, look at what we had. We had a positive number, we had a whole number, and I still ended up with a one answer as a decimal, essentially. 1/3 is a decimal. So I had a decimal and a whole number. Most of the time, though, I find, and I've done this for a long time, I find that if this is a whole number, most of the time these two answers are whole numbers. Every once in a while, like here, we get a decimal, right? And these are my x-intercepts. You have 3 other problems to do from that section, all right? So 4 total, you need to pick 3 other ones. Make it happen. Ask questions if you need to.